Nobody in the aerospace industry expected it to go this smoothly. On May 7th, 2026, SpaceX lit up all 33 Raptor 3 engines on Starship V3's Super Heavy Booster 19 at a brand new launch pad that did not even exist 12 months ago. Full duration, full thrust. Every single engine igniting in sequence on a pad that had never hosted a full Starship stack before. The ground shook. The flame trench split the fire in two directions like nothing the world had ever seen on a launch pad. And the entire industry watched, because what SpaceX just pulled off at Pad 2 is not something any other rocket program on the planet has ever done at this speed or this scale. This is not just a story about a static fire test. This is a story about how one company rebuilt its entire launch infrastructure, redesigned its rocket from the ground up, and then proved it all worked in a sequence of milestones that has left engineers, analysts, and competitors struggling to catch up. Let's go through exactly what happened, why it matters, and why the rest of the industry is paying very close attention right now. First, you need to understand what Pad 2 actually is, because calling it a launch pad undersells it completely. Pad 2 is a complete rethinking of what rocket launch infrastructure should look like when your goal is not just to launch a rocket once, but to launch it again and again and again on a schedule that resembles an airline more than a space program. The original Pad 1 at Starbase in Boca Chica, Texas, handled the first 11 Starship flights. It did its job, but it was also damaged repeatedly, required significant refurbishment between launches, and was designed in ways that limited how fast SpaceX could turn around the vehicle for the next flight. The very first Starship launch in April 2023 shattered the concrete underneath the rocket so badly that debris was launched hundreds of meters in every direction. SpaceX scrambled to install a steel water-cooled plate before the next attempt. It worked well enough, but it was also a patch, not a solution. Pad 2 is the solution. SpaceX started construction on the flame trench foundations in January 2025. The orbital launch mount was installed by May 2025. Water deluge system testing began in September 2025. And on February 16, 2026, SpaceX completed the first full-scale water deluge activation test at Pad 2, flooding the flame trench with hundreds of thousands of gallons of water in a precisely timed sequence designed to suppress the shockwave energy and thermal forces of 33 simultaneous engine ignitions. The footage circulated across the space community within hours, because watching that volume of water surge through an entirely new flame trench design was something nobody had seen before. This was not a patch. This was engineering built from first principles. Here is what makes Pad 2's design fundamentally different from anything that came before it. The original Pad 1 allowed exhaust to escape in a 360-degree pattern around the base of the rocket. That approach worked for smaller vehicles, but was inherently destructive at Starship scale. Pad 2 changes the geometry entirely. A bidirectional flame trench channels the exhaust through two defined openings, directing the fire and pressure away from the launch structure in a controlled path. There is also a new ridge cap system between the two flame diverters, and a water-cooled top deck on the orbital launch mount itself. 3 separate water delivery components, each with its own tank supply and pressurization system. And the pressurization technology itself is new. The old system used banks of high-pressure gas tanks. Pad 2 uses gas generators that burn oxygen and methane to convert liquid nitrogen into gas, which then pressurizes the water supply. The entire system is faster, more reliable, and built to survive launches at a cadence that Pad 1 was never designed to handle. When Flight 12 launched on May 22, 2026, observers watching the liftoff footage immediately noticed something different. The exhaust cloud split cleanly in two directions from the base of the rocket, exactly like the exhaust split seen on Saturn V launches from Kennedy Space Center's Launch Complex 39A decades earlier. That visual was not accidental. It was the result of the flame trench design working exactly as intended. For a rocket that is the most powerful ever built, that kind of controlled, directed exhaust management is not just aesthetically impressive, it is structurally essential. Without it, the pad would have absorbed forces that would have required weeks of repair before the next launch. Now, let's talk about what actually happened on the path to that launch. Because the sequence of testing milestones that led to Flight 12 is exactly where the industry was shocked into attention. March 9th, 2026. SpaceX rolled Booster 19 out of the megabay at Starbase and placed it on Pad 2's orbital launch mount for the first time. This was the first time a version 3 Super Heavy booster had ever been mounted on Pad 2. The booster arrived with only 10 of its 33 Raptor 3 engines installed because SpaceX was using this initial campaign primarily to activate the pad itself rather than demonstrate full booster performance. March 16th, 2026. SpaceX conducted the first ever static fire test of a version 3 vehicle. 10 Raptor 3 engines ignited on Booster 19 at Pad 2. The test ended early due to a groundside issue, but SpaceX confirmed that all installed Raptor 3 engines had started cleanly. That single sentence mattered enormously. Raptor 3 is an engine that had never flown before. Getting clean ignition on every single installed engine on the very first attempt is exactly the kind of result that tells engineers their design assumptions were correct. SpaceX posted the result and called the initial Pad 2 activation campaign complete. Booster 19 then returned to the Mega Bay. The remaining 23 Raptor 3 engines were installed, bringing it to a full complement of 33. And on May 7th, 2026, Booster 19 rolled back out to Pad 2 for the test the entire industry had been waiting for. A full 33-engine static fire, full duration, full thrust. SpaceX held the booster down on the pad, ignited every single Raptor 3 simultaneously, and ran the test for 14 seconds. The result was described by SpaceX as a full duration and full thrust firing. Every engine performed. The pad survived without significant damage, and Flight 12 was now cleared for launch. To understand why the industry was shocked, you have to understand what those 33 engines actually produce when they fire together. Each Raptor 3 generates approximately 280 metric tons of sea-level thrust at a specific impulse of roughly 350 seconds. Multiply that across 33 engines, and you get approximately 9,240 metric tons of combined thrust. That is more than any rocket engine cluster ever ignited on a launch pad in human history. It is enough force to lift the entire Empire State Building off its foundations, and Pad 2 absorbed that energy on its first full test without flinching. Ship 39 was going through its own testing campaign in parallel. At the new Massey test site, a facility purpose-built for upper stage validation, Ship 39 completed cryo-proofing operations across several days, testing its redesigned propellant system and structural strength under the cold temperatures and pressures it would face during actual flight. SpaceX also ran squeeze tests that mimicked the forces of a future ship catch by the mechanical arms on the launch tower. Ship 39 passed all of them. Then in April 2026, Ship 39 rolled out for its own static fire campaign, igniting its 6 Raptor 3 engines for the first time. That was another first. The first ever static fire of a version 3 Starship upper stage. By May 7th, both halves of the first V3 stack had completed their static fire campaigns. SpaceX stacked Ship 39 on top of Booster 19 at Pad 2 on May 19th. The full stack stood approximately 48 feet tall. On May 22nd, 2026, at 5:30 in the afternoon local time, Starship Flight 12 lifted off from Pad 2 for the first time. The flight itself delivered the kind of mixed result that SpaceX's test philosophy considers a success. All 33 Raptor 3 engines ignited at liftoff. One engine shut down during ascent, a minor anomaly on a vehicle with 33 engine redundancy. The booster and ship completed hot staging successfully, with Ship 39's 6 Raptor engines lighting up to continue toward space as the booster separated. The liftoff itself and the behavior of Pad 2 during the launch were textbook. The exhaust management performed exactly as designed. The water deluge system protected the infrastructure. The launch mount survived intact. After separation, Booster 19 attempted its boost back burn and encountered issues, completing only a partial burn before experiencing a hard splashdown in the Gulf of America rather than a controlled landing. Ship 39 continued its trajectory, deployed modified Starlink satellites, and completed a controlled splashdown in the Indian Ocean. The FAA has since required a mishap investigation into the booster anomaly before Flight 13 can proceed. That investigation is ongoing, but the launch itself, the pad performance, and the upper stage behavior all generated data that feeds directly into the next vehicle. This is exactly how SpaceX designed the program to work. You do not wait until everything is perfect. You fly when you have validated the critical systems, you capture every data point the flight generates, and you use that data to make the next vehicle better. The booster anomaly on Flight 12 is already informing the design refinements that will make Booster 20 more capable. The pad data from the launch is already being analyzed to accelerate the turnaround timeline for Flight 13. Now step back and look at what SpaceX has actually built here. In roughly 16 months, they designed, constructed, and commissioned an entirely new orbital launch pad from a blank piece of land in South Texas. They redesigned their rocket across 5 simultaneous work streams, producing a new ship, a new booster, new engines, and a new upper stage test site in parallel. They validated every major system through physical testing before flight, not through simulation. And they launched the most powerful rocket in history from a brand new launch pad on the vehicle's first ever integrated flight test, with the pad performing exactly as designed. The rest of the aerospace industry is watching this and doing the math, because what SpaceX just demonstrated at Pad 2 is not just a technical achievement. It is a proof of concept for a completely different way of building and operating space infrastructure. The old model says you build one pad, you protect it carefully, you refurbish it slowly, and you launch infrequently. The new model says, you build infrastructure designed for high cadence from the beginning. You accept that testing will occasionally cause damage. You design for rapid repair rather than avoidance. And you prioritize learning speed above all else. Pad 2 is already serving as the template for every future Starship launch facility. The design is being replicated at Kennedy Space Center's Launch Complex 39A in Florida. Also, where SpaceX is building another Starship launch pad. The lessons from Pad 2's flame trench, water deluge system, and Chopstick arm upgrades are all feeding into that construction. SpaceX is not just building a second pad. They are building a scalable launch infrastructure system that can eventually support the flight cadence required for Mars missions and lunar operations under the Artemis program. The Chopstick arms at Pad 2 have also been upgraded compared to the original Pad 1 design. The actuators controlling the catch arms have been changed from a hydraulic system to a fully electric system. That change improves responsiveness and reliability for booster catches. SpaceX has stated that future V3 booster catch attempts will come after additional flights validate the landing and recovery sequence. Booster 19's splashdown on Flight 12 will contribute data toward that validation. The path to a V3 booster catch at Pad 2 is already being built, one flight at a time. Version 3 Starship, operating from Pad 2, is targeting a payload capacity of over 100 metric tons to low Earth orbit in fully reusable configuration. That number reshapes the economics of every space mission currently being planned. Satellite constellations that would previously require 10 launches can now potentially fit on one. Lunar surface cargo delivery becomes feasible at a scale that was previously theoretical. Mars missions that required architectural compromises due to mass constraints can now be rethought with more payload margin. The entire mission planning landscape for space programs over next decade shifts when a vehicle with this payload capacity becomes routinely operational. SpaceX has been working toward this moment since 2019 when the first small Starship prototypes began hopping a few hundred meters above the Texas coastline. 7 years of iteration, explosion, rebuilding, and refinement have produced the machine and the infrastructure that launched from Pad 2 on May 22, 2026. The industry did not expect it to come together this fast. The simultaneous redesign of 5 major systems, the construction of a new test site, the activation of a new launch pad, and the first flight of a generation-defining vehicle all happened within a window that most analysts considered optimistic by at least a year. SpaceX proved them wrong, not by cutting corners, but by moving faster with more parallel work streams, more physical testing, and a deeper tolerance for learning through failure than any other program in the history of human spaceflight has ever demonstrated. What happened at Pad 2 was not luck. It was the result of a methodology that the rest of the industry is still figuring out how to match.